All right, third hour coming at you, homework 41. We got to add, we got to subtract, we got square roots, cube roots, fourth roots, putting them all together. It starts off easy, like square root of 9, you're like, I got that, that's 3. Square root of 121, I got that, that's 11. Boom, negative 8, not much work to that. So that didn't last very long. Obviously, once you start, the easy ones are over with. Then we got problems where you got to do some work on. Let's do some of those. Let's keep it with square roots. Let's do 2. 9 square roots of 50 minus 4 square roots of 98. So the rule for adding and subtracting is pretty straightforward. This and that, they got to be the same. Clearly right now you do not have the same stuff underneath the root sign. This is the 50, this is the 98. So for this homework 41, jump over with the 50, jump over with the 98. We're going to factor tree those guys down. So 50 is 2 quarters, 5 and 5. This is 2 and 49, 7, 7. So it really doesn't take long to factor tree them down, break them down. So you've got 9. In place of the 50, you got 2, 5, 5. So 50 out, 2, 5, 5 is in. 98, he's out. In place of 98, the 2, 7, 7. 2, 7, 7. Boom, boom, boom. So if it's square root, we're looking for pairs. We're looking for 2 of a kind to get out of there. Here's a pair of 5s. Here's a pair of 7s. Taking it on out. We remember the rule. There's 2 of them on the inside, but you only write it one time when you get it on the outside. Don't forget about the 9's already out there. So here's 9 times 5. Kind of looks like that. 4 times 7. Again, 2 on the inside. You only write it one time on the outside. So let's clean it up. 9 times 5, that's 45 square roots of 2. This is 28 square roots of 2. So now it's a problem where you have like terms. This square root of 2, that square root of 2. With like terms, you can go ahead and add and subtract. 45 of them, take away 28 of them. What is that, 17 of them? That's left over, that's your answer. So there you go. All right, let's get it all out of the way. That didn't all erase very well. Okay, number 3, so we've done square roots. How about number 3, we jump up to some cube roots. Let's go 2 cube root 135 plus 7 cube root 625. Hopefully you can see that. Don't know how good the green's coming through there. So we're in that same jam where we have this is 135, not the same as 625. So we got to factor tree it down, create like terms with our radicals so that we can add and subtract them. So run over to the side. We'll 135 this. We'll 625 that. We'll factor tree these down. What is that? 135 divided by 5. What was that, 27 times? 3 and 9, 3 and 3. So we got 135, a bunch of 3s and a 5. 625 is a whole lot of 5s. Like 5, 125, 5, 25, 5, and 5. So you got a lot of 3s, you got a lot of 5s. Let's put it together. So we had 135, but he's gone. You're replacing that with a 3, a 3, a 3, and a 5. We had 625, but it's just all 5s. Okay, so process is still the same. We are still hunting, trying to find groups that match up, but now we're at cube root. Cube root. So square roots, we're looking for 2 of a kind to get out of there. Cube root, 3 of a kind. So hunt you some 3 of a kinds. Here's 3 3s. Here's 3 5s. Grab it, get it out of there, grab it, get it out of there. And then you remember the rule is still the same. Even though you took 3 of them out from underneath, there's 3. You're only writing it one time when you put it on the outside. Don't forget about your 2s already out there. So it looks like that. Your 7 already out there. 5 comes out. And you only write it one time on the outside. You got cleanup here to do. You got cleanup there to do. So this becomes 6 cube roots of 5 plus 35 cube roots of 5. And again, like terms. Cube root of 5, cube root of 5, dun dun dun. Now they're like terms. Now you can add and subtract them. That's our job today. 6 of them, 35 of them, 41 cube roots of 5. You're like, yes sir, go Pioneers. Okay, so that was cube roots. Well, let's just take it up a notch. How about fourth roots? Number 4. Number 4. Fourth root. Let's go. All right, 243 minus 10, fourth root of 48. So we still have to follow the rules for having like terms. You still got to get the same stuff with your radicals. So whether it's square root, cube root, fourth root, that doesn't change. Therefore, grab the 243, grab the 48. Let's get to work. So factor tree those down. 243, that is a whole lot of 3s. 3 and 81, 3 and 27. Yeah, that's 5 3s. 3, 3, 3, 3, 3. 48 is that's 2 and 24, 2 and 12, 2 and 6, 2 and 3. That's mostly 2s. So factor tree those down. Got a whole bunch of 3s, got a whole bunch of 2s. Let's spell it all out. 3, 3, 3, 3, 3. Fourth root of 2, 2, 2, 2, 3. Now we've bumped it all the way to fourth roots. So if it's fourth roots, we're not looking for 2 of a kind, we're not looking for 3 of a kind, now we're looking for 4 of a kind. So here we go. Here are a group of 4 and a group of 4. Rule is still the same. Even though we grabbed 4 of a kind underneath, when you get it out of there, you only write it once. So this will be 3, fourth root. So it looks like that. You had 4 of these, take it out, you only write it one time. Don't forget about your 10. He's already out there, and you only write that 2 one time. Oh yeah. So this cleans up to be 3, fourth root of 3. You got to take care of that, so that's 20, fourth root of 3. But you have accomplished your goal. You've written the same common terms. They're like terms now. Fourth root of 3, fourth root of 3. You got this. -7. Whoa, that is a really crazy 4. All right, third hour, there you go. 3, 20, -17. Got an answer. So we can add, subtract square roots, cube roots, fourth roots. Feeling pretty good. Let's throw a couple more at you with numbers and letters. Maybe some variables sneaking in there. All right, let's do this. Let's put in some X's with our numbers. Okay, again, this time you got 28, you got 175, not the same. You have an X here, you have an X third there, not the same. We got to get numbers and letters, everything's got to coordinate. Let's work on the 28, let's work on the 175. We're going to factor tree those all the way down. 28 is 2 and 14, 2 and 7. This is 5, and what is that? 175 goes in there 35 times. Oh, that makes sense, because now this is 5 and 7. So we got 2 times 2 times 7, 5 times 5 times 7. Okay, 7 quarters, it's good. We've got to spell it all out right here. So 6x square root 2, 2, 7 with an x. The 175 breaks down here, but don't forget you've got x to the third to deal with also. So you have 5, 5, 7, x, x, x. All right, we have scaled it down. We just did square roots, cube roots, fourth roots. Back to square roots. Back to two of a kind. One pair of twos, one pair of fives, one pair of x's. So when you grab it coming out of there, you're only going to write it one time. Don't forget, outside you've got a 6 and an x times a 2. Here you got a 2, 5 times x. So, grab the 2, get him out. Grab the 5 and the x, get him out, get him out. Clean up this, clean up that. 6 times 2, 12x squared is 7x. 10x squared is 7x. Now we're feeling a lot better. X, 7x, x, 7x. Like terms are happening. Now we've got the green light. Now we can proceed. We can add them up. 12 of them plus 10 of them. 22x squared to 7x. So adding, subtracting these radicals means you've got to build it to where you've got exactly the same stuff. You've got like terms. I like it. One more example. Last one, let's jump it up to some cube roots. And I like throwing in the variables. Let's do one where we got to throw in some letters. Okay, same thing, cube root, but underneath we've got 24x, here we've got 81x to the fourth, not the same, not the same. So, we've got work to do. Let's get on our factor trees. How about a 24 and an 81? See what they scale down to be. 24 is 2 and 12 and 2 and 6, 2 and 3. So what is that? 2, 2, 2, 3, boom, boom, boom. 81, oh, that's just a lot of threes. Okay, so we've got the 24 broken down, we've got the 81 broken down. Let's get it in there. 24 is 2, 2, 2, 3x. 81 was all those threes. And don't forget, you got all the threes, but x to the fourth, you've got to write your 4 x's. So we've got everything spelled out. We've got everything spelled out. We have gone back to the cube roots. And anytime you have cube roots, we're looking for 3 of a kind that we can get out of there. There's one group of 3. Oh, and oh. All right, jump it, grab it, move it. Let's get it. So we already have a 15 on the outside and an x. Here's a 2. Same rule, only going to write it one time. You've already got a 2 on the outside, but you're adding a 3 and an x. So it looks like that. The 2's come out. The 3's come out. The x's come out. You got mess to clean up, 15 times 2, so that's 30x, cube root of 3x. This is 6x, cube root 3x. You're done. You've done all the work you can do. Let's take a look and see if you've got like terms. Here is x cube root 3x. Boom. X cube root 3x. Boom. They're exactly the same. We can add and subtract them. Subtracting this time, 30 minus 6. Looks like 24x cube root 3x. So our job today, we got to add them and subtract them, square roots, cube roots, fourth roots. There you have it.